Okay, so we're looking at simultaneous equations. What we'll do, so we're going to have two videos here. One will be the substitution method, and the other one will be the elimination method. But before we get too much into that, I just want to spend a few minutes just going over the basic concepts, just to make sure that that's all locked in. Okay, so let's have a look at this. So let's say we've got the point 2, 3 on the Cartesian plane there. Okay, now that is part of the line 2x minus 1. So here is 2x minus 1. Okay, I'll just draw him through there. Okay, so it goes through -1, okay, and has a gradient of 2. All right, and the point 2, 3 lies on the line, which means if we substitute in x of 2, do the number crunching, we get a y of 3. So in other words, this point here, the coordinates of this point here satisfy that equation. Okay, but we can have another line as well. Let's draw in y equals -x plus 5. Okay, so it has a y-intercept of 5, because when x is 0, y is 5, and has a gradient of -1. But that point 2, 3 also lies on it, because if we substitute in x is 2, number crunch this side, we get y of 3. Okay, so what we can say is this point here satisfies both equations, and both that one and that one. Okay, so they have this one point in common, which is 2, 3. Okay, that is the only point in the universe that they intersect, and so therefore that is the only xy coordinate or pair, ordered pair of xy numbers that satisfy both of them. So the whole idea with simultaneous equations is to hunt down this elusive pair. Okay, now you can do it graphically, just like I just did then. Okay, so if I just gave you that one and a grid, you could draw those two and just figure out, read off it. Okay, that's where they intersect. Bang, 2, 3. All right, that is one way, but you will need to know how to do the substitution method and the elimination method. All right, so let's get into this. So the substitution method. All right, so I've got two different questions here of differing complexity. All right, now first things first. Okay, this stuff is really dependent upon your setting out. You've got to be quite meticulous with your setting out. Otherwise, you're just going to cause all kinds of problems. That's the first thing. Second thing, here's what I like to do. I believe this helps a lot. If you've got -2, or like I subtract 2, turn that into a plus negative. Okay, adding -2 to something is the same as subtracting 2. Same over here. I've got subtract 4, turn that into plus -4. That really helps. Okay, you'll just make it a little bit more bulletproof. Okay, so what we do is we give each one a name. Okay, so that we can refer to each equation. So there is a point out there in the universe that the xy coordinates satisfy both of these. Okay, so substitution method is basically, it does what it says on the tin. Okay, you get this one and substitute it into that, thereby wiping out one of the unknowns. So what that's saying is, well, let's assume we're at this position. If we are at this mythical point of intersection, then these y values are the same. So let's just make this equation equal that equation. All right, so what that looks like is 3x plus 4 equals 6x plus negative 2. Okay, because if we're at that point, these two y values are the same anyway. So we might as well just say, you know what, all of that equals all of that. Now it just comes down to plain old algebra to figure out who's who in the zoo. Okay, so this is where this plus and negative comes in handy. Because if I want to, okay, I've got to get all the x's on one side and I've got to get all the numbers on the other. Okay, so you can do things like this. You go, righto, well, to get rid of that, I just add 2 to both sides. Because negative 2, you know, up here, let's do it here, negative 2 plus 2 equals 0. Boom. So if I just add 2 to both sides, that'll be gone. So 4 plus 2 is 6. Okay, I want to get all the x's on one side, so I'm going to subtract 3x from both sides. So I've got 6x minus 3. Sorry, 6x minus 3x. So what's that? 3x. Oh, boom, that's easy. X equals 2. Sweet. Okay, I'm going to call that C. Okay, that in itself is an equation. And then I'm going to substitute it back into one of these. Doesn't matter which one. I'll go to A because it's on top. So this is a nice little symbol for you're substituting it in. Actually, we probably could have done that. Really what we're doing is we're substituting A into B. Okay, so C substituting into A. So wherever I've got an X, I'm going to put a 2 for A. So Y equals 3 times 2, just to make that different to an X, wrote it fairly small, plus 4, so that's 6 plus 4 is 10. Okay, so my XY coordinates equals 2, 10. Okay, state it at the bottom there. Okay, now let's just have a little check. Let's look at this one here. Does that actually work? You should always know that you're right. That's the beauty of this thing, is that when you've finished, you can always check. So let's just look at B. We haven't used B very much. 2 goes into there. 6 times 2 is 12. Plus negative 2. 12 plus negative 2 is 10. Boom. Y is 10. Sweet. It works. Okay. This one here, basically the same concept. Okay, I'm going to label them first. Alright, now I'm going to go A, substitute into B. Alright, so, okay, easy done. These are the same Y values now. If we found this mythical position, we're assuming that we've got it. These two numbers are the same. Alright, so I've got 2 outside of x plus negative 4 equals negative 3x plus 2. Alright, again, now it's just a straight up solving thing. Get rid of the brackets. That's 2x plus negative 8 equals negative 3x plus 2. Alright, so let's get everything on one side. So to get rid of this on this side, I've got to add 3x to both sides. So that's 5x there. To get rid of that, I add 8x to both sides. So that's gone, and now 2 plus 8 is 10. Cool. X equals 2. Okay. Righto, let's call that C. Gosh, which one are we going to go into? I'll go into B again. Why not? Okay, so C is going to go back into B. Okay, so it's going back into this one. Substituting in. So Y equals, so everywhere I've got X, I put the 2. Okay, so that's negative 6 plus 2, which is 4. Okay, so my amazing XY position is 2, 4. Okay, so again, you should always know whether you're right, because you can substitute it back in and check it. So if I go pick this one here, if I got an x of 2, that's 2 plus -4. Hang on, what have I done? Oh, look at that. Boom. Glad you picked up my deliberate mistake. 2 goes into that. That's -2. Yeah, 2 plus -4. That whole brackets works out as -2. -2 times 2 is -4. Done. Okay. So that just proved the check. Okay. I made that mistake there, but when I substituted back in just to check in my head, it didn't make sense. All right. So there you go. It's foolproof. Okay. You should know whether you're right or wrong. Okay. Okay. So that's the substitution method. I reckon it's the easiest one. But just watch your setting out, label things, see how I've got, all of that in line. Okay. All of that in line. Okay. It just makes things so much better. Okay. Be careful with your setting out and use these groovy little symbols like that. Okay. Because it just tells the reader what's going on. It helps you to figure out what you've done later on, and it's just a good idea. All right, next one's going to be elimination.